Thanks, Stephen. I've been asked to stand behind the podium here, so I'm normally kind of a wanderer. I'd like to move out there, but I guess for the camera purpose, they've asked me to stay here, stay put. As Stephen just introduced, our research and our research team has really focused a lot of effort in the last number of years on automated robotic milking, and I've had the pleasure of speaking to this audience a couple years ago, I think, on some of that work. And today I'd like to kind of continue some of that discussion, highlighting some of the results that we've had, particularly in the last year or two, on these fronts. And when we think about some of the research that we're doing, and particularly in my lab, two of the kind of primary focuses when we think about automated milking and some of the opportunities there are, first and foremost, is looking at ways of trying to improve and optimize kind of the voluntary nature of milking in those systems, and that's really kind of a keystone to the success of those systems, not only from the cow's perspective, the behavior of the cow, the production of the cow, the health of the cow, but also for the dairy producer, who's again looking to optimize the efficiency of use of that system, maximize the amount of milking through those equipment to optimize the return on the investment of the milking equipment itself. But then also labor efficiency, which is also a big component of the reason why dairy producers have moved towards these systems within our industry as well. And then the second, and that speaks more to some of the nutritional kind of aspects of our research, is thinking about how we also meet production needs through lactation, and specifically in terms of encouraging high peaks and persistency in cows. And again, that's not necessarily unique to robotic milking. We want to do that in all our milking systems and different management systems that we have on farm. But because we do have the opportunity to individually supplement cows in robotic milking systems, we've been kind of focusing on that aspect of that, looking at that as kind of an extra piece or added value, so to speak, to robotic milking that we can take advantage. For today, I want to kind of focus on three examples, so to speak, of research that we've been doing in this area, just some recent results related to this topic of management and nutrition in robotic systems. And these are kind of the three areas I want to touch on. First, focusing on nutrition in terms of that there's many approaches and there's probably not one size that fits all. Secondly, cows need to be motivated and trained to go and milk, and talk a little bit about some of the challenges and opportunities there. And then lastly, again, back to the nutrition side, thinking about opportunities we have for precision feeding and this idea that we can improve our supplementation and potentially even going to this morning's presentation, our opportunity to improve efficiency and reduce waste in these animals as well. Starting with the first topic in terms of there's one or not one size fits all in terms of nutritional approaches, and this actually stems out of a DFC, Dairy Farmers of Canada, cluster project that we started a number of years ago already, specifically focused on looking at management variation in robot farms across Canada. Some of the initial work was actually led by our colleague here, Robert Matson, who was doing a master's at the time, looking at the association between management variability and production on robot farms across Canada. We led a large study on that. One of my subsequent grad students, Brandon Van Soest, who did his PhD with my group, took over that project, specifically looking at some of the nutritional aspects related to these farms and some of the variation that we saw there. And this is an excerpt of a table that comes out of the paper, one of the papers that he published out of his PhD. A lot of numbers here. I don't need people to be that concerned with the individual numbers themselves. But what we did in these farms, and we had, in this case, we had data from over about 150 farms across Canada, broken out by region, East, Quebec, Ontario, and the West. And we quantified not only the dietary differences on all these farms, but also the nutritional or nutrient content differences on all these farms. And what we noticed is that we see a lot of variability. And Canada is a big place. We have a lot of different feeds that we feed, a lot of different growing conditions. We have a lot of different management across the country. And as a result of that, we see a lot of variation in nutritional practices on these robot farms, both across regions, but also within region. And so probably not too surprising, because of that amount of variation, when we actually went forward in our analysis to look at how some of that variability actually correlated with or associated with production differences on these farms, we didn't actually find that many associations. Again, likely because we have so much variation within the industry. And so one of the questions that we did ask is, how does the robot diet ingredient and nutrient content of the diets that we provide, both at the robot itself, but also at the feed bunk for those cows, how does that associate with production differences? And interestingly, we didn't find a whole lot of things like I just mentioned. Two of the highlights as far as kind of primary associations that we did find is that milk yield, on average across the country on those robot farms, about 37 kilos, was associated with the fat content of the PMR. So every percentage point in fat that was in the PMR of those diets was associated with about a kilo more milk. And probably that's explained by just fat supplementation in those diets, particularly the supplementation of palm fat or palmitic acid in those diets, which again is widely used within our industry as an energy source for cows in our diets. And also the major forage source of the PMR is basically those herds that either fed a barley silage-based PMR or corn silage-based PMR made more milk than those feeding an alfalfa haylage-based PMR as their primary forage source. And again, some of that might be related to forage digestibility, but it's actually also confounded a little bit with region, as we have certain areas of the country where those forage bases are more prevalent than others. Even though we try to control for that in our analysis as much as possible, that's probably still some of the confound there. And so teasing the direct impact there out is not necessarily that easily done. What's interesting in this analysis, or this paper at least, was the fact that when we looked at the actual milking behavior of the cows, going back to the idea of around voluntary milking and what actually influences milking behavior in these cows, fitting in with some of the other studies that we've done over time, the actual nutrient and dietary differences on these farms was actually explaining very little in terms of differences in milking behavior between these cows. The only kind of difference that we found there on the bottom here is that the milking frequency of the cows, at least, was negatively associated with the NFC, which is the non-fiber carbohydrate component of the diet. So basically a kind of a measure of energy content of those diets. And again, most of our farms in Canada, most of our robot farms are what we call free traffic, where again, we tend to have a little bit of a variation between the energy content we provide at the feed bunk versus that which we provide at the robot. And that's helping get those cows to the robot. And so again, having a little bit of differential in energy content, or at least non-fiber carbohydrate content there, having a positive association. But actually most of the variability in milking frequency and milking behavior in these cows is actually related to housing and management on these farms. And again, this is just two examples. One is a housing related thing, the difference between free and guided traffic systems tending to have or significantly associated with a very large difference in average milking frequency, as well as feed availability. And that's again something that's not unique to this study, and we've shown that in other studies as well, is that differences in feed availability have a huge impact at the feed bunk in terms of actually getting cows to the robots themselves. And in this case, more feed availability through more frequent feed push-ups was associated with more milking frequency in those farms as well. And so again, like I kind of started off with the take home on this, is what this is demonstrating to us is that yes, there are a lot of varied approaches in nutritional management on our farms. There's probably not one size that fits all. And when we actually look at some of the variation associated with milk production variation on these farms, a lot of it comes back to the housing and management on these farms, the cow comfort, all those kind of things. Yes, nutrition is very important, but again, we're often limited in terms of what we can achieve with nutrition based on some of those other factors. And if we don't get those things right on our farms, we're not going to let those cows not only allow the diets to do what they're supposed to do, but also let the genetics of those cows do what they're supposed to do as well. Another area that we've been focusing on specifically is looking at motivation of cows to go milk voluntarily, and then the role of training in that as well. When we think about what motivates a dairy cow to go to a robotic milking unit, and I've kind of alluded to this already, it's a multi kind of factorial thing. And it's feed, and we talk about feed in the robot, we talk about feed at the feed bunk, which I just spoke about, But then at the center of this is the cow herself and the environment that that cow is in. And it's not just the environment, like I was saying before, but it's the cow herself in terms of her own behavior, her own behavioral profile. A couple of years ago when I was here, we shared a bunch of research that we've been doing focused on some of that individual behavioral profile of these cows, specifically what we call the personality of the cows. And I'll show you an example here too, where the cow, we can do all kinds of different things, but again, the cow is a cow, and her individual behavioral kind of variation or personality is actually going to dictate what she does at the end of the day. And so we need to keep that kind of in mind when we're thinking about the way that we manage cows in these systems. We recently completed a interesting study earlier this year looking at, again, the impact of motivation for cows to milk in robotic milking systems. There was some old research to suggest that maybe particularly in lower producing cows, that udder pressure doesn't necessarily drive a cow to a robot. And so people have gone on that for years saying, okay, it's not necessarily udder pressure in cows, it's the feed. If we take the feed away, the cow stops coming to the robot. And so we ran a study last year where we kind of looked at two different kind of dichotomized things that affect voluntary visits to dairy cows in the robot. And one was by actually extending the milking interval on cows. So basically making those cows wait longer to go to the robot, which would potentially increase the amount of pressure within the udder of those cows to increase the amount, or basically her maybe willingness or desire to go to the robot. And then the second was actually removal of the concentrate from the robot to see how that influenced her behavior as well. We did this on a very short-term basis at the Ontario Dairy Research Centre down the road here. Interested in, again, kind of the immediate response of these dairy cows. We didn't want to extend these things too long because we didn't want to have any kind of negative long-lasting impacts both on the behavior and production of these cows. But compared to the baseline period where the cows had access to feed in the robot, they had a shorter milking interval, allowable milking interval in the robot. What we see is that numerically, actually, when we extend the milking interval in the cows, you can see it here in the blue line versus the green lines here, that basically the frequency of visits, both total, voluntary, as well as rejections by the robot, those go up, indicating that there's probably still some impact of that desire of those cows to go to the robot. And again, those cows were still getting feed, so again, whether or not it's just the desire to get feed or some impact of that udder pressure influencing the cow, there's probably something there, but again, we couldn't necessarily tease it out. On the other hand, when we did remove the concentrate, we saw those cows start to decrease in terms of their visits. So again, there's lots of interest in the industry today in terms of trying to think about ways of saving money, maybe reducing the amount of feed that we provide in the robot, and I think there's some opportunities there, but we also have to be careful in terms of the behavior of those cows too, because we do still know that that is one of those motivating factors for that cow to actually make it to the milking robot. In that same study, as I mentioned before, then this was done by a former PhD student, Anna Schwanke, who completed her PhD this past summer. She was also very interested in some of that cow-to-cow variation. And again, just as an example of that, just to show you, one of the things that she looked at was, again, the kind of the behavioral profile of these cows, classifying the different personality types of these cows. And again, we employ some different methods to do that. In this case, she had the cows ranked on a score of social explorative. So basically, these are cows that are more social, more explorative within a pen, particularly when we put them into a novel situation. And basically, what you look at, if you look from the left to the right, is basically these are kind of your less sociable, your less explorative cows. These are the more social, more explorative cows. And fitting in with a variety of other projects that we've done in this area, what we see is a direct correlation with, in this case, not only the milking behavior of these cows, but even the milk production of the cows. And again, right, where you see this nice line here, where basically as we go from left to right here, these cows that are more social explorative have higher milk production. And we've seen this in a variety of our different studies. We've seen this with other behavioral traits as well. Some more active cows, and this is where we're still trying to figure some of these things out. Some of our studies have shown more active cows actually seem to adapt maybe quicker to the robot, but at the same time, some of these more active cows actually probably have more energy expenditure, and they're actually putting more energy into some of their activity relative to what we want her to put her energy into, and that's milk production. And some of those more active cows actually have lower milk production as well. And so again, just highlighting the importance and kind of the difference that the cow even makes in some of these things. So we can change settings on the robot, we can change what we do at the feed bunk, but still we have to be mindful of what the cow herself is going to do in these different situations, and there can be quite a bit of cow-to-cow variation in that. Lastly, just one other example, and I thought I'd highlight again using some local data here, again part of another recent study looking at again the association between what we do, I mentioned before, in our national study showing an association between robot visits and, say, push-up frequency on those farms, just feed availability. This is another analysis that we're doing, again, using some recent data from one of our studies where we had a number of robot farms from here in West Ontario looking at differences in feeding practices on these farms, not only feed push-ups, but even feed delivery. And this is actually percentage of total robot visits across the day, looking at kind of diurnal patterns in those robot visits. Where on the left side here, we have an example of a situation where cows are being fed twice a day, and you can probably guess where cows are being fed based on the peaks in milking activity. And so we see a tie here between the milking behavior and the eating behavior of those dairy cows, where we see peaks in milking activity occurring after those cows are delivered fresh feed, as opposed to the right side here, where again, the average milking frequency and total visits was not any different, but we see much more consistency in this pattern, and this is a farm where they're using an automated feed delivery system. And again, I'm not saying every farm has to go to automated feeding, but it just shows the impact of that consistency in terms of feed and feed availability on the behavior of those cows and the impact that might have on their motivation to milk in these systems as well. Another area that we've been focusing on in the last couple of years, and we've done a couple studies on that I wanted to highlight, is the training of cows to robots. We get a lot of questions about what is the optimal thing that we can do from a training perspective. How do we get these cows to figure out what they need to do in these systems? The initial study that we did was led by a PhD student of mine, Jessica Brazier, who's in the back of the room here. She's got a poster actually on this study, so I'd encourage you to go look at that poster, but I'll just briefly describe a couple of the results from it. Very interesting. We took first lactation animals that were in around 85 days in milk, and they had been milked on the parlor, never been milked on the robot, and we exposed them to three different training methods or no training. So we had a control with no training. We exposed them to either just the environment of the AMS, we exposed them to the mechanics of the AMS, so we basically brought them into the environment, but then also brought the arm out and the sounds of the robot so that they could get kind of accustomed to that. And then the final one, they got exposed to the environment, but also just got a pellet reward. So they got some of the feed, and so we thought that would be kind of a positive kind of reinforcement type thing, where the mechanics might be more of a negative type reinforcement, right? So again, a noise and sounds that the cows had never heard before. What was interesting, and really Cole's notes here, is that at the end of the day, the cows that actually performed the best were the ones that were exposed to the mechanics of the robot. And those cows that they had the highest milk production in the time period after adaptation, as well as the cows that had the environment. So again, the ones that we presumably gave kind of the most negative experience from a training standpoint, and we actually saw that. We looked at the ease of entry of those cows, and those cows had the worst kind of behavioral response during training, but then post-training, those cows actually seemed to adapt the best. And so probably having some kind of negative conditioning actually improved them, because basically when we actually put them on the robot, they knew what that negative aspect was, and then they got milked, and then they got feed, which was probably a positive thing too, and they actually did better, as opposed to actually our pellet cows, who would have presumably viewed that as maybe a positive kind of thing, getting feed in the robot, and we think that's a good thing. However, those cows actually, from a behavioral standpoint, did the worst when we put them on the robot. And I think I have that here on the next slide. If we look at actually their milking visits, and this is over the 2 weeks after introduction, the cows that actually received the pellet actually did the worst. And so probably some aspect of those cows maybe initially getting pellet thinking, oh, this is great, and they get that for their training period, and then we actually put them in the robot to milk them, and they go, hey, wait a minute, this was a good experience, but now it's maybe not so much, right? And so, again, this got us thinking in terms of, okay, what can we combine these maybe positive and negative aspects together and see whether or not that has an impact on these animals. And so that's basically the follow-up study that Jessica did earlier this year as well, looking at then training that involved the exposure to not only the environment but also the mechanics in the pellet all at once. And so trying to put all these different things together. And very interestingly, and just again, some quick results on this, what we demonstrated, and this was actually with not virgin heifers, sorry, with first lactation heifers that were just coming into springing heifers, so they're just coming into lactation. So we did this 2 weeks before calving on first lactation animals, so they'd never been exposed to any milking system before. And what we see is actually quite a difference. Those animals, and again, not too surprising, but we see a very strong positive response in terms of voluntary visits, less fetching, more voluntary milkings, more total visits to the robot on those cows that were exposed to that training, and in association with that, an improvement in milk production, about 2.2 kilos more milk per day per cow over the first 21 days after those cows transition onto the robot. So again, providing us some good evidence that training is very positive and can be positive for those cows, as long as probably that we're including the right elements in those training on those cows. The last thing I want to touch on kind of briefly is opportunities to precision feed. And again, we've done a number of studies looking at, again, differences in kind of nutritional approaches. I started with kind of our national survey. We've done a lot of cow level studies on this over the years. And we're trying to kind of work towards opportunities to not only improve health, but also production and also efficiency. And again, this is just kind of scratching the surface on some of this. We have potentially a new project starting with DFC next year, looking at, again, ways of trying to improve efficiency of production in robot farms by kind of targeting in on some of our supplementation, with the idea that if we can improve feed efficiency on these cows, we can also decrease nutrient excretion, improve or reduce our greenhouse gas production on those cows as well. Just as a couple of examples or things that we focused on is to date actually is looking at, again, how we design our rations from basically a kind of stage of lactation and production level, making sure that, again, we're trying to do that from the cow's perspective to best target those things. And specifically, some of our focus has been at looking at kind of times of greater needs in cows in these systems. And we know that there are situations where, again, cows have higher or lower kind of say energy demands, particularly that postpartum period where, again, the amount of feed energy that we get into cows doesn't necessarily always match her productive output. And again, the level of that kind of negative energy balance that we see in that early postpartum period can, again, relate to productive and health outcomes in these cows. And we see real good evidence of that actually in our robot cows. Another focus of our national study was to look at this. And so in another analysis that my former student Brandon did was to look at the level of what we call hyperketolactia, which is basically elevated milk BHB or milk beta hydroxybutyrate based on first test BHBs from Lactanet. And what Brandon did was summarize across, again, a large sample of robot farms across Canada, 162 farms, the mean prevalence of elevated BHB on first test, both in primipairs and multipairs cows. Again, the numbers here fit within kind of our national averages, so not much different than what we see in conventional herds. We had some previous research which suggested that maybe we see a bit more actually in robot farms. We can talk about that later if you'd like. But what was interesting, and it kind of goes against some of the dogma that's out there today, which would say, or I guess new dogma, so to speak, which is that maybe having a high BHB in cows is not necessarily a bad thing. As long as the cows remain healthy, they remain productive, they don't become sick, right? Their reproductive success is good, then having a bit more BHB, it just means the cows are working a little bit harder, they're pumping a little bit of fat off their back, and they're doing okay. But what we see in these robot herds is actually a negative association between the level of that hyperketolactia, or the amount of basically energy mobilization, and their production, where these cows that are mobilizing a lot more fat are actually our lower producing herds. And we see an association between that, which suggests that we need to think about ways of potentially bridging that gap in terms of the energy on these cows, particularly in early lactation. And we have some other studies that we've looked at that within. So again, a couple studies that we've done over the years to look at that is trying to find ways of increasing supplementation in these early lactation cows. We did a study a number of years ago looking at supplementing sugar through molasses, saw some positive impacts on that. And then more recently, we did a study here in Southwest Ontario on a cohort of farms here supplementing glycerol, again, a bioproduct of, or a byproduct of the biodiesel industry. Again, a potential energy source in the animal, not a starch source that's going to have a greater negative impact on the rumen environment, causing acidosis and those kind of things in those cows. Just as, again, a kind of a proof of concept of what we can do for those cows in that early postpartum period and how that may translate into longer term benefits on those cows. And so what my former master's student, Clay McWilliams, did was on these farms, we had 4 dairy farms that were supplementing glycerol through their robots to a group of cows on those farms versus a control pellet that did not have the glycerol. We fed it at 250 grams per cow per day for the first 21 days in milk, and then after that basically put all the cows on the same robot pellet for the rest of their lactation. What we found was that kind of interesting and fits with some of the other data that we'd have in this area is that those cows that were supplemented, basically their risk of ketosis was basically the same whether or not those cows were basically normal condition versus over-condition. And we know that typically our over-conditioned cows that are calving in with a high body condition score, those are cows that are at risk for having low intakes, for mobilizing more fat, going into more excessive negative energy balance, and becoming ketotic in early lactation. And that's what we saw in our control cows, where there was a higher risk of ketosis or elevated BHB, blood BHB in this case, in those control cows, in the cows that calved in with a high body condition score, whereas opposed to those cows that were supplemented, actually we kind of mitigated that and we saw a very similar risk of ketosis in those cows. And very briefly, and again, there's lots more results in this study, but just from a milk production, and I think this is where the rubber hits the road, so to speak. Very interestingly, what we saw here is we saw an improvement in association with that improved energy balance in those cows in early lactation. Saw an improvement in milk production, not only during the supplementation period of about 0.7 kilos of energy-corrected milk per day, but throughout the remainder of basically up to mid-lactation, up to 150 days in milk, we saw an improvement of just over 1 kilo of energy-corrected milk on those cows and a higher peak and basically more persistency. And again, I just use this as an example of the opportunity that we have here. I'm not saying everybody has to go out and feed glycerol to their cows, but it's an example of what we do to these cows during this early postpartum period, and particularly meeting the energy needs of those cows can have a very significant impact, not only on their health and performance in that period, but also throughout the remainder of their lactation. And that's really kind of what we're hoping to achieve in a lot of kind of our continuing work in this area, is trying to focus on better identifying and supplementing these cows so that we can not only optimize production, but like I said before, optimize the efficiency of these cows and reduce also the amount of nutrient excretion and our waste that we see in these cows as well. So very quick take-home messages. We have a lot of varied approaches in managing diets. We have a lot of different ways of kind of getting at the same result, and that's a good thing. We can manage, feed, and provide training so that cows are motivated to go and milk, and again, that involves, again, meeting basically needs of feed at the robot, feed at the feed bunk, but then also, again, managing the behavior of the cow, whether, again, that's her individual behavior, that's something that we can train into that cow, and then lastly there, we can strategically supplement cows as well. And so, again, quick highlights of things that we've been involved in the last number of years here. Just like to thank a variety of the people that supported this, including the Dairy Farmers of Canada, Dairy Farmers of Ontario, through some of the programs that they support also at the University of Guelph to make a lot of this research possible. So with that, thank you very much, and hope we can take a question or two.